Finally happened. It finally happened. They hacked the CSS. The CSS has been compromised. All hope is lost. It being kind of hyperbolic here, but new Chrome 0 day CVE 2026-2441 is under active attack, and Chrome actually put out their first patch for their first 0 day of the year, where attackers are exploiting CSS. So that part actually isn't hyperbole. The bug is a use after free in the way that Chrome handles CSS. I'll go into what all that means here in a minute. If you're new here, my name is Ed. I make videos about hacking, and it's a good time. Hit sub. I appreciate it. Yeah, so CVE 2026-2441, found by this gentleman here, whose name I'm not going to pronounce, I'm going to mess it up. CVS score of 8.8, a use after free bug in the way that Chrome parses and handles CSS, allowing a remote attacker to execute arbitrary code inside of the sandbox via a crafted HTML page. And while not a lot of details are out about this intentionally, Google does actively acknowledge that an exploit for this exists in the wild. So that means that maybe their threat analysis team or their telemetry has caught this exploit being thrown in the wild. Very interesting stuff here. How can one hack CSS, right? How is that entirely possible? Well, let's go into this, right? It's important to understand that Google Chrome, like any other piece of software, is just software, and the code underneath it that parses CSS, that parses JavaScript, is written in most of the time a memory unsafe language like C or C++. And guys, while we can't stop bugs like this from happening, one thing we can do is stay ahead of cyber actors with today's sponsor, Flare. Flare is a threat exposure management platform that allows you to see if you or your company's data has been sold on the dark web by cyber actors. One thing I like about Flare is they have a feed of events where you can go and search for interesting keywords that you're curious about that are happening on the dark web. One of them, obviously, is the recent Claude Open Claude Moltbooks thing. If you're not aware, OpenClaw, the very trendy AI agent thing, there's actually now a Facebook equivalent for those AIs to talk to each other called Moltbook. And if you're curious about how hackers are potentially using Moltbook to do nefarious transactions, you can search Flare events for mentions of Moltbook, and people are actively talking about it in illicit Telegram channels and on places like breach forums right now. And as usual, guys, Flare's bread and butter is the identifiers. If you put in your identifiers into the Flare system, if any of your identifiers come up in conversations about Moltbook or otherwise in any of Flare's feeds, you will get an alert from Flare telling you exactly where it was found and what you can do to prevent more damage. Guys, the best way to help the channel out is to go interact with the sponsors. Go give Flare a shot. You can use Flare for free right now at the link below. Flare, thanks again for sponsoring the video. Back to the video. So the actual exact technical reason for the vulnerability is a use after free in the way that the browser parses these things here, this font feature values for a particular font name, right? So I'm not a front end guy. Okay, I have a real job. But what you can do here is specify for a certain font name, maybe that you have different style sets where like you can say the style for this version is this, or the boldness for this version is this. You basically can add additional features to fonts if you so choose. Okay. Now in the actual code for this, there is a feature called CSS font feature value maps. Okay, so to go into this, we have to talk about what a use after free is, right? A use after free is exactly what it sounds like. You have a pointer to some structure in memory, right? And then you free it, but that pointer is still being used. What you're allowed to do is effectively confuse the type that it points to by pointing it to two different types at the same time. The classic example is you have struct cat and struct dogs, and there are two types that overlay each other. You have an int in spot 1 and 1, and you have a pointer in spot 1 and the other. What can happen here is if a use after free occurs, it allows a pointer to point to both a controlled cat and a controlled dog. An attacker that can modify the ID can set the ID value to a particular pointer and then use that to modify parts of the program, right? It gets very hairy very fast. And so a use after free occurs here because we have two global pointers, Randy and Frank, and I'm able to create a new dog whose name is Frank and create a new cat whose name is Randy. But all the while, if I delete the dog or delete the cat, I free them, but I don't delete the pointer. So when I do follow-on operations like print dog, for example, I can use after free the Frank pointer. Even though it's freed, it'll now contain information from Randy. And you can see this pretty quickly. We can take this example here, run it in GDB, we'll run it. So if I make new dog, delete the dog, make a new cat, because I have a use after free primitive, what I can do is now print the dog anyway, and you'll see that I'm trying to dereference that long number, the ID, as a pointer, which is crashing the program, right? Now, again, if this were an attacker controlled value, I could turn this primitive into an arbitrary read, leak memory out, or an arbitrary write. It gets very messy very fast. Now, what's cool about browser exploits is at the end of the day, you're actually exploiting the browser through a bug that manifests in JavaScript or CSS. And unlike a lot of Chrome bugs that I've seen, this one has a POC that you can actually test to see if your browser is currently vulnerable. Mine is not, so I can't actually run this, but I can show you what's generally happening here. So again, remember, use after free. We free something, but somewhere else in memory, it is still tracked in being used. Okay, so we have that font feature set for test font. We create this style set parameter. Again, I'm not a CSS guy. I don't know exactly what's happening here. But you see we have this function. What we're able to do is look into the style sheet and find the CSS rule 0. Then we can iterate over all of the rules in that map, right? This is just converting the CSS rules that are manifested here into a map you can iterate over in JavaScript, okay? What they're doing is basically iterating over that map, and they are deleting an entry in that map and setting it to something else, right? Which is really, really interesting. Now, this looks all well and good, but the problem is if you actually go to the source code in Chrome before this commit occurred, they are using a reference to those values in the actual code that is doing the CSS font feature value map, right? So they're iterating over this, iterating and pointing to a reference, but underneath the hood, the pointer that is pointing to the thing is not accounting for the fact that it may have been deleted in the meantime. So as they're iterating over it, you could potentially delete it, kind of like a race condition going on here, that enables a use after free. And so the solution to this problem is all they have to do is, I think the short-term solution for Google is instead of doing a reference, they're doing a move, right? So they take this this font map that's manifesting here, and instead of pointing a pointer to it and iterate over it, they're gonna make a copy of it and move the copy over into that map, which is really interesting. And again, I think they have a potential to do in the future that gives them a better solution for this. Like, what is it? This addresses the immediate problem of iterating while modifying, right? So, this is basically them saying, hey, instead of us having this thing where we point to a thing and the underlying map can go away, let's just make a copy of it and then, iterate over it that way. And just in case you're new to this industry, right? This is not the first time we've had 0 days like this in browsers. Actually, browser exploitation is an active problem in cybersecurity. Like, for example, last year, the tech giant being Google addressed 8 0-day flaws that were being exploited in the wild by threat actors, meaning there is somebody out there who has a server that serves you malicious JavaScript or CSS and is using that to pop browsers. And there are entire teams at Google, like their tag team, their threat analysis group, and Project Zero, whose whole life goal is to remove these kinds of vulnerabilities from the code base. Super interesting stuff. Previous bugs existed in the almost native graphics layer engine Angle, which is basically the almost hardware layer that Google uses to render data in the browser. Just like anything else, if you are parsing media formats, those media formats are going to be very complicated, and as a result, going to have potential vulnerabilities that can arise in memory unsafe languages. And the classic question from the class, would Rust have solved this problem? Actually, yeah, this is one of the common areas that Rust is very much designed to solve, right? A use after free is one of the things that Rust by design does not allow to happen. There's a lot of talk about if Rust actually is or is not a good thing for memory safety or for software safety. I wouldn't want to write all of the bin utils in Linux in Rust, for example, because there's no meaningful attack surface here. But browsers have the very unfortunate task of literally parsing arbitrary user data, and most of the arbitrary user data is media data, so very complicated parsing formats. So doing that in Rust is a much safer option than doing it in C++. That being said, that is actually why the Mozilla team created Rust, right? They maintain Firefox, and Firefox, a lot of their components, I think actually their CSS renderer is written in Rust, right? Which makes it very difficult to exploit from a memory safety standpoint. But low level, what can I do? Okay, the answer is very simple. Just update your browser. Just go get the latest Chrome version, and maybe there's latent 0 days hiding in that Chrome version too. But if people are throwing 0 days at you, maybe you deserve it. I don't know. Anyway, thanks for watching. I appreciate it. We'll see you in the next one. Take care. Goodbye.